Okay, hi again. I decided to split this last section up into 2 different days. So we're going to do the solving natural logarithms today separately. They're just like solving regular log equations. When you have log on one side and something else on the other, you're going to rewrite it in exponent form to get rid of the log. So if it's a natural log, it just means it has a base of an e instead of like the 10 or the other number that they give. But we're still going to do it the same way. Reuse the circle method and rewrite this in exponent form. So e to the 4th power equals this. E to the 4th power equals 3x plus 5 squared. Now you don't want to square that out with the FOIL method. Instead, we're going to take the square root of both sides to get rid of that square. So let's do e to the 4th first. It's going to be long decimal, but we're going to approximate it. So e to the 4th power is approximately 54.60. 54.60 approximately 3x plus 5 squared. So now we're going to square root both sides. That will take that off. Whenever you take the square root, it does have to put the plus and minus. So you have plus and minus the square root of 54.60. Let's square root that. Second function square root, last answer, that is going to be 7.39. Plus and minus 7.39 equals 3x plus 5. So we have 2 separate problems there. We'll do the positive first. 7.39 equals 3x plus 5, and then we have to do negative 7.39 equals 3x plus 5 and solve each one of those. So minus 5 on this one, you get 2.39 equals 3x. Divide both sides by 3, you get x equals 2.39 divided by 3. I miss my helpers out there doing this part for me. 0.797. 0.797. It's approximately. So that's one answer. And then this one we have to minus 5. We get negative 12.39 equals 3x. Divide both sides by 3. Negative, not decimal. Negative 12.39 divided by 3 is 4.13. X is approximately negative 4.13. Those are the 2 answers that we get. You do want to make sure you plug them in and make sure that they do work, because you can't take the ln of a negative number. If you remember what that graph of the ln looked like this, that means there's no negatives in the domain, so you can't take the ln of a negative number. But when you put this in here, whether you put negative or positive, it is going to get squared, so it's not going to be negative. So you're okay. Both those answers do work. Let's try this one. Just remember, all ln's have a base of e. So when you rewrite this, it'll be e to the 0.1 power equals x. That's pretty easy. E to the 0.1 power equals x. So whatever e to the 0.1 power is, so plug that on your calculator. Second function, e to the 0.1 power. X equals 1 point, we'll just round to the nearest hundredth. X equals 1.11. On your homework paper that I'm going to upload for you, it'll tell you how it wants you to round your answer. So just follow those directions. Put your base of e to the 21st power. That is a huge number. E to the 21st power equals this stuff, 3x minus 9. I would not put this on your calculator yet because it is going to be very, very large. So I'm just going to go ahead and add 9. E to the 21st plus 9 equals 3x, and then divide by 3. You can do this whole thing on your calculator at once. Just make sure that you either put parentheses or do this part, hit enter, and then divide by 3. So let's do that. Let's see. E to the 21st power. Make sure you go down out of the exponent and do plus 9. That is a large number. And then divide by 3. So answer, x equals 439. 605, 247.8, comma, 439,605,247.8. That is your answer. And this one, put your e, rewrite it. E to the 12th power equals x plus 2 over 3. You're going to solve that for x. This is just a number. E to the 12th power is just a number. First thing you're going to do is times by 3 over to this side to get rid of this. Times by 3 to this side. And then we're going to 3 times e to the 12th equals x plus 2. Then you're just going to minus 2 to the other side. Minus 2. So you can put all this in a calculator at one time. 3e to the 12th power minus 2 is whatever your x is. So let's do it all at once. 3 e to the 12th power. Make sure you come down out of the exponent and then do a minus 2. Let's see, I get x equals 4, 8. Oh, I need another 8 before my column. 488,000. 262.37. Ran out of room. 488,262.37. So the key to these is to put the e, rewrite them in exponent form, and then solve the equation that you have left. Solving an exponential equation. So those were natural log equations. They were given to us as natural logs. This one, you don't see natural log in that anywhere. So this one is already in exponent form, and you're going to use natural logs to solve it. So you want to get the part that has the e to the power by itself. First thing you're going to do is subtract this over to the other side. So you have 7 times e to the 2x power equals, oh, the decimal's in the wrong place there. That's a minus 2.5. Let's see, that's 17.5. Yeah, and then we're going to divide off this 7. So we have e to the 2x power equals, what is 17.5 divided by 7? 2.5. Okay, so you want to get it to that part where you have e to the power equals a number. Now that it's in exponent form, you can take the natural log of both sides in order to get the variable that's in the exponent down to the front. We did this with log equations. If your variable is in the exponent, the only way to get it out of that is to take the log of both sides. So we're going to take the log of both sides. It's just that we're going to do a natural log instead of a regular log because of the e. Because this base is an e, we're going to do the natural log of both sides. I'll do it in a different color. So we're going to take the natural log of this side and the natural log of this side. And that lets us use those properties that says you can take the exponent and bring it down to the front now. So 2x times the ln of e equals the ln of 2.5. And guess what the ln of e is equal to? Ln of e has a base of e. So the ln of base e equal to e. Whenever this base and this number here match, remember what that was? That means e to what power is e? 1. All of that equals 1. Anytime that you see the ln of e, it's just equal to 1. So you can just take it out. You don't need it. So that means 2x equals the ln of 2.5, and then divide by 2. So whatever the ln of 2.5 divided by 2. Ln is on the left-hand side of your calculator, so hit ln of 2.5, close your parenthesis, hit enter, and then divide it by 2. Divide by 2 equals 0.46. 0.46. X equals 0.46. That's what you get. Let's try another one. Anytime it's in exponent form, you're going to use logs to solve it because your variable is up in the exponent. The only way to get it down is to use those log properties. Since the base is an e, that's telling you that you know you have to take the ln of both sides. The ln of e to the x plus 1 power equals the ln of 30. You can't do the ln of one side and not do it to the other. Whatever you do to one side of an equation, you have to do it to the other. So that's just taking the ln of both sides. Now you can bring this down and put it in the front. X plus 1, since an expression, I'm going to put parentheses around it, times the ln of e, like that, equals the ln of 30. Hopefully you haven't already forgotten that I just said the ln of e equals 1. We don't need it, so just leave it off. So we have x plus 1 equals the ln of 30. Now you're just going to subtract 1 to get x. X equals, now be careful, don't do the ln of 29. You have to do the ln of 30 and find out what that's equal to and then minus 1 from it. So let's do that on our calculator. Ln of 30. Find out what that's equal to and then minus 1. So you get x equals 2.40. That's what you get. Let's try one more. So you always have to get the part that has the e by itself first. So you're minus 7.2 over to the other side first. So we have e raised to the 2x over 5 power equals 9.1 minus 7.2 is 1.9. Okay, now that you got this part by itself. Now you're going to take the ln of both sides. If you leave enough space, you can just slide it in right here, like that. Take the ln of both sides. That lets you bring this exponent down to the front. So you have 2x over 5 times the ln of e, which is equal to what? 1. Take it out, you don't need it. ln of 1.9 on that side. So we have 2x over 5 equals the ln of 1.9. We just need to solve it for this x. How do you get rid of this 2/5? You have 2/5 times x. So if you want to get rid of the 2/5, then you're going to times it by 5/2. Times by 5/2 over here. So we have x equals whatever 5/2 times the ln of 1.9 is. So you're going to put this on your calculator. You can put 5/2 or you can put 2.5. It doesn't matter. 2.5 times the ln of 1.9. 1.60. 1.60. X equals 1.60. Hopefully you're following along okay. That is it for that one. Okay, this is bringing us back to the compounded continuous interest formula that we already learned. You already had it on a quiz. It has the E form in the formula. So amount in the account is equal to the principal times E raised to the RT power. R is your rate as a decimal and T is your time in years. So an investment of $100 is now valued at $149.18. The interest rate is 8%, compounded continuously. It tells you that. That means you know you're using this formula. About how long has the money been in there? How long has it been sitting in that account? So the amount in the account is now worth $149.18. The original amount you put in was $100 times E raised to the RT power. R is 8% as a decimal. That's 0.08, and there's your variable, T. That's what we're looking for. How long did it sit in that account? So we have to solve this. Just like the other equations that we just did that had an E in them, we need to get this part that has the E by itself. So we're going to divide by 100 first. So 149.18 divided by 100 is, I knew that, 1.4918. Just moves your decimal twice to the left. I wasn't thinking. That's gone. You have e to the 0.08t power. So on this one now, to get this variable down out of the exponent, you're going to take the ln of both sides. So just slide the ln on both sides of your equation. So you have the ln of 1.4918 equals the ln of e times, or raised to the 0.08t power. Now you can bring this exponent down. So you have ln of 1.4918 equals 0.08t times the ln of e. What's the ln of e equal to? 1. We don't need it. So to solve for this t, you're just going to divide by 0.08. So time is equal to, let's see, ln of 1.4918 equals, and then divide it by 0.08, and you get 4.9997. So we're going to say it's about 5 years. If you put $100 in the bank and you leave it there for 5 years at 8% interest, you'll end up with $149.18. We had a problem on our homework a while back that said, how long would it take for your money to double? I said, just pick a number, pick any number you wanted. In this case, it would be 200. You started off with 100, and I don't remember, I want to say ours was a 7% interest. And I told you at the time that there is a way to solve this algebraically, but you don't know how to do it yet. That's this way. That's how you would do it. Instead, when we did it, we said, let this be y1, let this be y2, and see where those two things cross. I want to say our answer was maybe 10 years or 9.9 years that we had to leave it in there. But now we know an algebraic way to do it. So no matter what these are, you're going to divide, by this number here. So 200 divided by 100 is 2. If your money is doubling, that's always going to be a 2, whether you started off with 1,000 and it doubled to 2,000, or if you started off with 500 and it doubled to 1,000. Whenever you do this division, you're always going to end up with a 2. That's why it didn't matter what number you picked, because when you divide that over, you're always going to get a 2. And then e to the 0.07t power, bring that down, take the ln of both sides. That's how you do it algebraically on that old paper that we did a while back. Let's do this one. An initial investment of $200 is now worth $315.24 after 7 years of continuous compounding. Find the interest rate. Different variable this time. We're still using the same formula. A equals P times e to the RT power. The amount in the account is now worth $315.24. We originally put in $200 times E raised to the R. We don't know, but we do know we left it in there for 7 years. So it's gonna be a 7R. That's your interest rate times your time. So we have our variable up here. It's an R this time though. We still need to get the E part by itself, so we're gonna divide this 200 over to the other side. Let's see what that's equal to. 315.24 divided by $200. That is 1.5762. Notice I didn't round that. That's the exact answer. Try not to round in a problem until the very end if possible. E to the 7R. Whenever your variable is in an exponent, the only way to get it down out of the exponent is to take the log of both sides. This time we're doing the ln, the natural log, because the base is an E. If the base were a number, we would take the log of both sides, the common log, the log base 10. But since the base is an E, we're going to take the ln of both sides. So this side is just the ln of 1.5762 equals, bring the 7R down now. So we have 7R times the ln of E, which is, you got it, 1, don't need it. And now just divide by 7 to solve for R. So R equals whatever that is. Let's try it. ln of 1.5762. Get that answer first, and then make sure you divide by 7 after that. You get 0.065, 0.065. So that as an interest rate would be 6.5% interest. 6.5% interest rate. And that's how you do that one. I think that's our last one. Let me check. Yep, that is our last one. That just has our homework assignment on it. But I'm going to be adjusting the homework a little bit so you don't have quite as much to do at home, and hopefully you aren't getting frustrated and getting stuck. So just make sure you're using my email, watsona@pickle.org, and let me know if you have any questions or if I can help you in some way. I mean, what else am I doing at home, right? Just me and the dogs. So maybe I'll do some videos from home, and you can, and the dogs can be the star. I'm sure that they would love a little screen time as well. So I miss you guys. Hope you're doing well, and I'll talk to you soon. Bye.